This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the arctangent and arccotangent functions. Let's examine the sine and cosine of our first quadrant angles. Sine of 0 is 0. Sine of pi over 6, 30 degrees, is 1/2. Sine of pi over 4, 45 degrees, is 1 over root 2, or root 2 over 2. Sine of pi over 3, 60 degrees, is root 3 over 2. Sine of pi over 2, thinking of the unit circle, will tell us that that, of course, is 1. Cosine of 0 is 1. Cosine of pi over 6 is the same as the sine of pi over 3, which is root 3 over 2. Cosine of pi over 4 is 1 over root 2. Cosine of pi over 3 is the same as the sine of pi over 6, which is 1/2. And cosine of pi over 2 is 0. Knowing this, we can construct a table of the tangents, remembering, of course, that tangent is sine divided by cosine. So looking at this table, to get the tangent of 0, it'll be 0 divided by 1. The tangent of pi over 6 will be 1/2 divided by root 3 over 2, etc. So let's go ahead and do that. 0 divided by 1 is 0. 1/2 divided by root 3 over 2 is 1 over root 3, which of course could be the same thing as root 3 over 3, but I prefer to think of it as 1 over root 3. 1 over root 2 divided by 1 over root 2. Something divided by itself, of course, is just 1. Root 3 over 2 divided by 1/2 would be root 3 over 2 times 2, or root 3. And for this last piece, 1 divided by 0, well, you can't divide by 0. It'll give us an undefined situation, so there is no value of the tangent at pi over 2. That's undefined. So knowing this, we should be able to answer many questions about the arctan and arccotan functions. So here's my first example. I want to say the arctangent of root 3. So we're going backwards from this table. If the answer is root 3, what is the question? Remember, for an inverse function, y becomes x, x becomes y. Answer becomes question. So the arctangent of root 3 would simply have to be pi over 3. Now the arctangent of 1, again, we're going backwards. We look at our table. Arctangent of 1, well, if the answer is 1, what is the question? The question is pi over 4. And we get that from that position. Now how about the arccotangent of the square root of 3? What will that be? Well, that tells us then that root 3 is the cotangent of theta. So if that's the case, we can take the reciprocal of both sides. The reciprocal of cotangent is tangent, and the reciprocal of root 3 is 1 over root 3. So if we look at the table, going backwards from 1 over root 3, tangent of what is 1 over root 3? Tangent of pi over 6 is 1 over root 3, and we get our answer is pi over 6. Recall that a function has an inverse if it passes the horizontal line test. So a horizontal line can only cut the function in one point if it's going to have an inverse. But the tangent function is such that any horizontal line will cut it in multiple points. So we have to ask ourselves what part of this function would pass the horizontal line test. Let's look at this primary period. If we just focused on this, that would pass the horizontal line test. So this portion of the tangent function would indeed have an inverse. And there it is. So that portion of the tangent function goes from negative pi over 2 to pi over 2. Those are the x values for the tangent. So for the inverse, those would be the y values. That is the range. So the range of the inverse tangent function will be values between negative pi over 2 and pi over 2. It's round brackets because we never actually get to pi over 2 or negative pi over 2. Those are asymptotic. So if we are looking for a value of the inverse tangent of something, it must be in that range, from the negative first quadrant to the first quadrant. So here's an example. The inverse tangent of negative 1 equals theta. How are we going to do this? We're going to, of course, say tangent of theta is negative 1. And what's our reference angle? Well, our reference angle is pi over 4. Why is that? Ignoring the negative sign, we see that the tangent of pi over 4 is 1. So the reference angle I'm interested in here is pi over 4, and I've got to decide which quadrants those values will be. So what do we know? Tangent is negative in quadrant 2 and quadrant 4. So our quadrant 2 angle will be pi minus pi over 4, and our quadrant 4 angle will be 2 pi minus pi over 4. So quadrant 2 angle is 3 pi over 4, quadrant 4 angle is 7 pi over 4, but our range was from negative pi over 2 to pi over 2. So what can we say about that? 3 pi over 4 is not in that range, 7 pi over 4 is not in that range. But the quadrant 4 number should give us an indication of where that should be. There's a coterminal angle for us to work with. If we visualize that, this is what we're interested in. This is a fourth quadrant angle with pi over 4. And we saw here that's 7 pi over 4. The question is there another name for 7 pi over 4? Of course there is. 7 pi over 4 all the way around is the same as negative pi over 4, starting at 0 and going in the opposite direction. Negative pi over 4 is in our range of the inverse tangent function. Remember, the range was from what? From negative pi over 2 to pi over 2. And negative pi over 4 is in that range. So our answer to that question is theta is negative pi over 4. Let's look at another example. Inverse tangent of negative root 3 is theta, which tells us that negative root 3 is tangent theta. And we need to find our reference angle again here. Tangent of what is square root of 3? Tangent of what is square root of 3? We can see that as pi over 3. Sine is root 3 over 2, cos is a half. Root 3 over 2 divided by half is root 3. So the reference angle here is going to be square root of 3, but we're dealing with a negative number, so again we've got to think about the quadrants where tangent is negative. Reference angle is pi over 3, tangent is negative in quadrants 2 and quadrant 4. But again, the problem is we have to think about our range. So fine, just to go through the process. Quadrant 2 would be pi minus pi over 3, 2 pi over 3. Quadrant 4, 2 pi minus pi over 3, 5 pi over 3. But neither one of these numbers are in the range from negative pi over 2 to pi over 2. But it's relatively simple to think, okay, pi over 3 is the reference angle. In quadrant 4, all I have to do is go in the opposite direction. So the answer to this question will be theta is negative pi over 3, or the inverse tangent of negative root 3 is negative pi over 3. Again, an inverse function exists if the original passes the horizontal line test. And if we're looking at cotangent, same issue. Any horizontal line will cross an infinite number of points on the graph. So which period am I interested in? When is this one-to-one? How can I restrict the domain of this so that I have a one-to-one function? And we're going to consider this primary period. So if we go from 0 to pi on the cotangent function, this will indeed pass the horizontal line test. Well, x becomes y becomes x. So if this point x is from 0 to pi, if I take the inverse, the y values go from 0 to pi, and that's our range. So our range of the inverse cotangent, the range of the inverse cotangent function was 0 to pi. And recall that our range of the inverse tangent was negative pi over 2 to pi over 2. But that's dependent on a primary period where the function is going to be one-to-one, i.e. pass the horizontal line test. So let's take a look at the inverse cotangent of negative 1. That means negative 1 is the cotangent of theta. And taking the reciprocal of both sides, the reciprocal of negative 1 is negative 1. The reciprocal of cotangent theta is tangent theta. So I get tangent of theta is negative 1, but I still have to consider the range of the inverse cotangent function. Reference angle here is pi over 4. Hope we know that by now. And where is tangent negative, since we're doing this off of tangent, tangent is negative in quadrant 2 and quadrant 4. So in quadrant 2, it's going to be what? Pi minus pi over 4, 3 pi over 4. In quadrant 4, it's going to be 2 pi minus pi over 4, or 7 pi over 4. The range of the inverse cotangent went from 0 to pi. What's nice about this is one of these two numbers is in that range. Namely, 3 pi over 4 is between 0 and pi. This is a function, can only have one single answer. My answer will be 3 pi over 4. So the inverse cotangent of negative 1 is 3 pi over 4. Let's look at one more example. The inverse cotangent of negative root 3 is theta. So negative root 3 is cotangent theta. we need to take the reciprocal of both sides. Reciprocal of the left, -1 over root 3. Reciprocal of the right, tangent theta. So indeed we get tangent of theta is -1 over root 3. What's our reference angle here? We can go back and check our chart, but that's going to be pi over 6. Where is cotangent negative? In quadrant 2 and quadrant 4. Where is tangent negative, which is what this question is asking, also quadrant 2 and quadrant 4. So in quadrant 2 will be pi minus pi over 6. In quadrant 4, 2 pi minus pi over 6. So again, quadrant 2, pi minus pi over 6, 5 pi over 6. Quadrant 4, 2 pi minus pi over 6, 11 pi over 6. And our original question was inverse cotangent. So we think of the range of the inverse cotangent goes from 0 to pi, and one of these two numbers is in that range, namely the second quadrant answer, 5 pi over 6. And that will conclude this lesson.